Chemistry 10H students, this is Mrs. Altman, and in this video, I'm going to be walking through how to write the formulas for acid-base reactions. So acid-base reactions are really similar to double replacement reactions, but instead of forming a solid, so you're not going to need your solubility rules for this, instead of forming a solid, you're going to form liquid water. And that is because the acid will be giving H+, the base will be giving OH-, they form HOH, which we can rewrite as H2O liquid. For acid-base reactions, you may assume that everything that is not water is aqueous. You will see some exceptions in your textbook, but the reason why you don't need to use your solubility rules is because the pH of a mixture actually changes the solubility rules, so they're really just not that relevant with with acid-base reactions. You can always assume that water is a liquid as opposed to a solid or a gas because all of these are occurring at room temperature where water is a liquid. Right. The best way to learn these is just by doing examples. So I'm going to work through these three. So it always helps to do pre-work, as you may imagine, having done a bunch of double replacement reactions. So this is hydrochloric acid. So you have to remember your nomenclature because it has hydro. That means that it is something that doesn't contain oxygen. So this is just chloride. Then I have magnesium hydroxide. Molecular equation I do nearly identical to my double replacements. Don't forget to put the parentheses around hydroxide. It's a really common mistake for students to forget that. I totally understand why. Here, I'm actually going to write it as HOH because I think for many students, it makes it easier to balance. But if you want to write it as H2O, feel free to do so. So then all I need to do is balance. I put that 2 here. The reason why I think it's easier to balance is because I can in my mind lump OH together as one item, which makes it easier to separate this H from HCl from this H from MgOH2. If you prefer to write it as H2O, feel free to do so. So for the spectator ions, it's just whatever is aqueous in the product. So not liquid, aqueous. And then for the net ionic equations, it's just a formation of liquid water. So it's always going to be the same for every single acid-base reaction. If you wanted to write it as HOH, that would be completely fine. I'm copying and pasting it because I know I'm going to need it 2 more times. So sulfuric acid, everything's going to have H+, but because this ends with IC, I know I'm looking for sulfate on my polyatomic ion sheet. Again, up to you if you leave this as H2O or HOH. Either way is fine. I have to crisscross again. And then to balance it, I end up putting a 2 here and a 2 here. I am ignoring the water while I write the spectator ions. And then for the net ionic equation, it is going to be the formation of liquid water. So I'm just going to copy paste it just to save a little time. Hydrochloric acid I've already done. I know it's made up by H and Cl. So then I just treat it just like a double replacement reaction. And then I just need to balance it. I put A2 here and A2 here to balance it. So for the spectator ions, I just list pretty much everything that isn't H or OH. And then for the net ionic equation, it will always be the same. Great. Thank you so much for watching and have a great night.